Hi everyone, this video is on singletons. So the singleton design pattern does two things. One, it allows only one instance of a class to be ever created. So through the run of your program, you can only create one instance of this particular class and no more than one, okay? Just one. Thus the name singleton, right? And it also provides access to this only instance of the class from every single function. So everywhere in the program, you can access this one singleton, and you also prevent more than one instance from created. So one instance accessible everywhere. That's essentially the main things about the singleton, this idea of singleton. Okay. Now so the singleton design pattern is designed to support this thing. So why would we can we do this without a singleton pattern? Well, you can create a global variable, but it has problems. If you create a global variable, then it's a global variable, which we all know is bad because you can do things like mask a global variable. If you declare a variable with the same name as a global variable, you will mask the global variable. So in other words, you will prevent access to the global variable, which is bad. Global variables are generally bad also because it means that it's really easy to accidentally overwrite it. Like you might mean to have a variable of the same name locally to prevent access to a global variable, but then you forget to declare and you just simply assign, then the global variable is gone. Um, it also actually, a global variable does not actually prevent multiple instances from being created. You could have a global variable that points to some instance, and when you try, and then you can make it point elsewhere, right? Like you can actually undo that one instance with a new instance. So global variables are not actually something that can replace singletons, even though it kind of can allow access from every single function, but you can't really sort of prevent bad things from happening. And singleton pattern is a cleaner solution than global variables. Okay, so how does a singleton work? Right? Like, what do we do? So when we're creating a singleton, what we do is we actually do this through static variables, static data members, okay? So over here, we have a constructor. Now this constructor, you will notice, it's actually not in the public section, it's actually in the private section, which means that only other member functions of this particular class can access this data member, this constructor. Okay, so this constructor that I have for counter, oops, it's not actually something that outside of this class I can use. So I can use it if it's a member function of this class, but not externally. Now, over here, I initialize that instance variable. So this variable is the data member is called instance. I initialize it to a null pointer. And what I do is I have another static member function called getInstance. Now, getInstance gives you access to this instance variable, and then you can use that particular instance to do whatever you need to do with it. Okay, so with this particular getInstance function, you check whether or not the instance pointer has been initialized. So basically, when the program first starts, it's a null pointer. So if it's a null pointer, and this is the first time we call the getInstance function, it will actually create the unique instance at that point. So this is called lazy instantiation. Okay, so it basically means that if it's not needed, it doesn't get created. But the first time it is needed, you call this function, it will create the object and then give you and then return the address of that object to the calling function. So here I have two, three functions, right? And what happens is when I first start the program, I create a variable called count and I call getInstance, which will create the instance of unique counter. So initially this was null, so now it's not. Now, at some point, I might go through this code, and I might call function one or function two. And when I call this function, I would call the getInstance function. And because this has already been created, get instance, the instance that I get is the one that I already created. So there was only ever one instance that was created. It was only done when the main made this call the first time. Now it doesn't have to be main that makes the call the first time. It could be anywhere. But the first time you call get instance, that one instance of the object gets created, and then we are good. Okay. So just to sort of to show what's going on, let's do a quick sort of drawn walkthrough of what's happening in this program. So here's my tablet. I'm going to turn it sideways so that it's a little bit easier to see here. Okay. So over here is my unique counter. So when I start, I have this pointer called count. Now count is a local variable. Okay, so it's a pointer, and it's whatever address is passed back from get instance. Now, my class, my class has a static data member here called instance. Now, a static data member is one that exists. There's only one instance. There's only one of these things for every single instance of unique counter. So there's only one of this variable for no matter how many instances of unique counter I create. So you think of this as sort of like a shared data member between all instances of unique counter. But there's actually only one unique counter that will get created. So what happens when the program is initialized, this instance variable, which is shared between all instances sorry, horrible handwriting. Um, this instance variable is a member of my unique counter class, but it is also something that this is a shared data member between all instances of this. Okay, and it doesn't have to be it exists even when there's no instance of unique counter, because that's what static does, right? So this instance variable is initialized to a null pointer. That's what this line of code does. So the first time I call this function, this get instance function in main, what will happen is it's going to go into this get instance function. It says, oh, is your instance variable a null? And it says, oh yeah, it's a null. So what I'm going to do is I'm going to make this unique counter object. Okay. I guess this is actually not a great picture of this. Okay, so this is think of this as the unique counters um, uh, instance variable. Okay, so it's something that we share. And then when we create the object, the actual unique counter, the instance of it, we make this pointer point to it. Okay, so this is the instance variable, and it is private to unique counter. So I have to have a unique counter object to get access. Okay, so it is attached to this, but it isn't necessarily part of this one instance. You sort of picture it as a separate thing that is shared. Everybody shares the same thing. Now, over here, what happens is when I call this function, it created this object and it returned it. So my counter in my main actually points to this one variable, which has a count, which is initialized to 0. Okay, so counter in main does that. Count it, sorry, it's not called counter, it's called count. So the count variable in main um, points to this one instance. Okay, and I can do all kinds of things like click and print, and I think every time I press click, it goes plus plus, and then when I print, it prints out how many. Okay, now over here, I am simply going back. I'm just randomly calling my random number generator, and it's either going to call function 1 or function 2. Now inside function 1, I have another count 1 variable. So what happens when I go inside my function 1? Well, there's a local variable called count 1, and it calls this get instance function. So at that point, we go in here and we say, well, is instance a null pointer? So is this thing a null pointer? And because it's not, count is assigned a pointer to the same object. It's just whatever the instance was, right? Nothing happens here. So now whenever I press click, whenever I see the word click, it would just simply go up by one. Okay, so every time I click, it goes up by one. I click again, it goes up by one. So this function would actually increase the count and so on. Okay, I think I actually increased it once here, so this should be two. So, and if I have to go into function two, it's sort of the same idea. This function two has a count variable, and I can call it something else if it makes it a little bit easier to see. Maybe I call it p, okay? So let's change this variable name to p. It really doesn't matter. It's just a local variable, right? But if I had this, then p would also point to this object, and every time, and when I click, it would just make this go up to 4. So what I'm saying is that no matter where I am, I will be accessing the same instance of unique counter. There's only one of these things, and this is how a singleton pattern works. Okay, you create, you allow only you don't allow generally you don't allow the calling of the constructor. That's why it's private. And you have this lazy instantiation function where you basically say, okay, when this object is created, you prevent it from being created. If it's already created, you only create it one time. If it was not null, it means it's already been created. Don't create it again. Just return it. And that's pretty much it. Okay. Thanks.